Hello everybody, how y'all doing? Today we are going to be going over the last lecture of calculus. This is actually not the last lecture, but I think this might be the last lecture I'll cover. Since next week's lecture is not covered on the exam, from what I've heard. It's covered on the paper portion. Maybe I'll do the last lecture for the paper portion, maybe not, I'm not too sure, so don't be waiting for it. But yeah, this is our last lecture for the exam that is on Thursday and Wednesday. Okay, and this one is about sequences and series. All right, so what is a sequence? It's a list of numbers or a list of functions or a list of sequences within a sequence. So I can do, I could put a sequence here, then dash sequence. And so this is a sequence of sequences, right? Or I could put functions. Let's see, g of x, all right? Well, actually, it would be like f2 of x or something like that. So this is like, sequences of sequences and sequences of functions. So that's what sequence, definition of a sequence is. So now we're considering this being frequent sequence. What are the first few terms? All right, and so all you got to do is consider n at different values. For example, a at 1. As you see, the sequence is a at 1, a at 2, a at 3, and so on until the n value. And so if they want the first few, that means we can, sub 1 for n. And so this will equal -1 to the 1 times 1 all over 1 squared plus 3, right? Second term of the sequence would be, a at 2, then you'd sub in, so it'd be -1 at 2 all over 2 squared plus 3. All right, and then so on, and that's your terms for a sequence. Now, it has a limit L, and we write, I'm not going to go through this definition precisely, but what this basically is saying is that if you take the limit of your a to the n, and it gives you a number, okay, which is L, then it converges. If it doesn't give you a number, it diverges, okay? So if you take your limit of a to the n and it goes to infinity, divergent. Goes negative infinity, divergent. If it goes, dne, divergent. But if it gives you like 1, 2, whatever value, convergent. That's all it says, right? So you see, if the limit of the function equals L and f of n equals an when n is an integer, is this, like, you don't really have to memorize this. It's not even given. All you want to know is that if you take the limit of a to the n and it gives you a number, convergent. Gives you something else, divergent. All right, and taking limit. So before, we didn't really have these rules for limits, but they're the same exact rules you would have for derivatives, for example, where if I'm deriving two variables that I'm adding, I can separate them into two different derivatives and derive them separately. And this is the same thing for limits. If they're adding, then you can take the limits of each one separately and add them together. And you see if there's a constant, same with integrals or derivatives, if there's a constant, the constant goes out, right, for integrals. And so same thing with limits, is that you can take the constant out, take the limit of the function. Division, same thing. You can take the limit of the top and the bottom, then divide. Same thing for multiplication. You can take the limit for one function and then, or like for one sequence, and then take the limit for the other sequence and multiply them together instead of taking the limit of both sequences at the same time. Minusing is same thing as adding. This last one, I don't think we're going to be using it, so I won't be covering it, since most of these you could just do using the other ones. And I feel like this is too complicated for you guys to do anyway. All right, so we're gonna go past this one. For each of the following examples, determine whether the sequence converges or diverges. So remember we said, if you take the limit of the sequence to infinity, and if you get a number, it converges. If you don't, it diverges. And so we have p to the n, and here it says, so this is a function and population at time n is years. All right, n is years. And so here what it says is where the population is assumed to change once each year. So each year the population changes. What is the population after a very long time? Very long time means you go to infinity. You don't know what time, so you just assume it's to infinity, right? And so all you gotta do is you take the limit of it, right? That it goes to infinity. So p of n, as n goes to infinity, equals the limit of the function itself, obviously, as, let me change this into a more nice, all right, and so what we'll get here is the function, which is 500n all over 3 plus n. And so how do you take the limit of this? Just divide the denominator and numerator by n, right? And so what you can do is 500, and since I'm dividing the top and the bottom by n, this is divided by 3 plus n divided by n. That's what I'm doing. I'm dividing the top by n, and I'm dividing the bottom by n, right? And so if I just do that, then what I'll get is these two will cancel out, right? These two will cancel out, but I'll get 3 over n. And so what I'll get here, what this will actually come to, is 500 over, and I'll get 3 over n plus 1. So because this part, what happened, that's a ugly curly bracket. What happened to this part is this becomes 3 over n plus n over n, right? If you have a common denominator, you can just split it like this. And so this 3 over n stays, but this turns into 1. And that's how I got this bottom. Now I can take the limit of this. 500, the limit of 5, this is constant, it comes out. 1 constant comes out. When I take the limit of 3 over n, as any division you have of your 3 over some variable, all right, as soon as this goes to an infinite long big number, if you go on your calculator and you do 3 divided by, let's say 10, and then you go 3 divided by 1,000, and you'll find out that this number is bigger than this number. So as you're dividing by an infinitely long number, the number gets smaller and smaller and smaller, and it goes to 0, right? And so that's how we know this. When n goes to infinity, this whole thing will go to 0. So what we'll get is 500 over 1. And so our limit goes to 500. And so the population, after a very long time, goes to 500. And you can see the graph here. This is 450, right? And you can see like up here, this is 500. And you see the population, after a very long time, starts to plateau at 500 and like not grow anymore. Okay. There could be any kind of reasons why the population stops growing, but that's your mathematical logic. All right. And so now we're gonna do a couple practices. Same thing here. You want to divide everything by n, but which n? Do you divide it just by n? So what you want to do is just divide it by the highest power. Okay. So the highest power is n squared, and it's the denominator's highest power. Right. And so n squared, and this is supposed to be squared, divided by n squared, divided by n squared. And so what you'll get is this will cancel out, right? This will cancel out, leaving you 6 and 17. This will stay, this will stay. This one will cancel out, this one will cancel out. And so if I were to rewrite this, what I'll get is 6 plus 3 over n plus 1 over n squared all over 17 plus 18 over n squared, n, minus 4 over n squared. And as you can see here, now you can take the limit. Before you could take the limit technically, but the reason that it won't really get you with an answer is because this variable will go to infinity, this variable will go to infinity, this goes to infinity, this goes to infinity, but you don't know which infinity is bigger. Don't forget, your infinities are not all the same. Like if I do, like if I'm doing 6, let's say for example 6 times infinity, and I compare it with infinity, this infinity goes to infinity way faster than this infinity because I'm multiplying it by 6, right? Or if I do infinity squared versus infinity, right? And so there's different sizes of infinities. It's not just infinity. And so that's why it doesn't really help you much when you take it, because everything goes to infinity. And now you got to compare which one goes to infinity faster, and you only get an answer. And so when you do this, though, and you take the limit, we know, like we said, as the denominator goes to a very big number, it goes to 0, it gets smaller and smaller. This goes to 0, this goes to 0, this goes to 0, and this goes to 0. What you'll get is 6 over 17. Right? And so this converges. Here we know sine, so our sine graph, okay, our sine graph goes like this, right? and it doesn't end, it keeps going. So as n goes to infinity, so will the whole limit, because this will just keep going. It will just keep going up, down, up, down, up, down, like until it goes to infinity. It will never stop. Like, up here we plateau at some number, but here we don't plateau, we just keeps going. And so this goes to actually infinity, and so it actually diverges, right? And so same thing here. Well, here is not actually the same thing, because the graph, so the graph for your tan, the graph for your tan goes like this, right? And so this is your negative pi over 2. And this is your pi over 2. And so if I take this graph and I do the arctan, because ours is, arctan. Arctan is similar, but it's turned by about 90 degrees, I believe. So instead of it going upwards and downwards, it'll go sideways like this. And it's the same thing, which is negative pi over 2 and pi over 2. But you see how it plateaus? Like if I told you take the limit at negative infinity, this would go to negative pi over 2. But since we're taking the limit in the positive infinity, this will plateau at pi over 2. And if you take your calculator, let's say you don't know this, but if you take your calculator and like you don't know the graph, how can you check the limit? If you take your calculator and you do arctan of a small number, you'll get some value. And then if you do arctan of a very big number, you'll get 1.57, okay? And then if you take that same big number and you take the arctan of it, even bigger than this, right? Like let's say you do, tan inverse of like big number, right? This will go to 1.57. And then if you do tan inverse of like a way bigger number, you'll find out it will actually still give you 1.57, right? And as you can see, this plateaus at 1.57, it doesn't grow anymore. And so that's how we know that the graph goes to 1.57. What is 1.57? Pi is 3.14, right? And so you divide this by 2, you get your 1.57. So our answer, your graph will actually plateau at pi over 2. Okay. One thing I'm actually not sure about, because your arctan is multiplied by 8. Okay. So this term, what we just did is this term, we know, goes to pi over 2. But obviously we have our 8 here. So you want to take your pi over 2 and multiply it by 8. Okay? And so this is times 8, which will equal 4 pi. Okay? Because 8 divided by 2 is 4. So you just get 4 pi. Okay? And so that's your two examples if you know the graph and if you don't know the graph. Here, for this one in specific, if you take the limit, we take the limit as n goes to infinity of ln at infinity, right? And infinity here. This is your ln of infinity. Unlike, so we do know I believe our ln graph goes something like this. Okay? But don't mistake this for your arctan. Or don't mistake this for other graphs that plateau. Your ln actually doesn't plateau. It just increments slowly, but it doesn't plateau. So if you take your ln of a big number and then you take a ln of an even bigger number, you'll get a different value. It doesn't plateau. And so this actually goes to infinity, right? And this also, now obviously this is infinity. And so what you get is infinity over infinity. And if we remember from Calc 1, you can use your L'Hopital rule here and take the limit. And so what L'Hopital says, it says if you have infinity over infinity, then you can just derive the top and the bottom and take the limit again. And so derive the top, you get 1 over n. And you derive the bottom, you just get 1. And by the way, we're deriving this. Derivative of ln n is 1 over n. Derivative of n is just 1. Now I can take my limit. As n goes to infinity, and we know if you divide by infinity, you go to 0. So this is 0 over 1. And so your limit goes to 0. Okay, and because this is a number, it does converge. This also converges. All right, so I hope that explains it. What is another way you could do this? I'm trying to think. I can't think of a way besides L'Hopital. Now, I don't think they'll will give you something like this on the test because obviously we're not getting tested on Calc 1, right? So if you took Calc 1, squeeze theorem can also help evaluate limits. Also, if you're interested to see the text for alterating. Okay, so you could use squeeze theorem to also do this. But we're not getting tested on this. This is Calc 1 material. So when we introduced this chapter, our motivation for studying sequences was that so we could work with series. And now we're going to start with a series. What is a series? Is just you're adding a bunch of, so you know how we said the sequence is a bunch of numbers or a sequence of sequences or sequence of functions. A series is you're taking this sequence and whatever's inside and you're adding them together. Okay, so as you can see, this is the sum, right? We're adding them together as an infinite series, all right? And so what is an infinite series here? You see, like it says, if we add up infinitely many terms, do we always get infinity, right? And so what this is trying to say is, let's say, in the lecture, they gave you an example that's n squared, right? And so what this is when you're taking the sum, you're starting at 1, and you're going all the way to infinity. So this will become your 1. So you get 1 squared plus second term 2 squared plus and so on. And if you keep going like this will actually give you infinity. Okay, but what if I give you a sequence of fractions? And you know how earlier we saw that some of them actually plateau. They don't go to infinity. And it's the same thing. Some of them don't. So if I give you like let me think, like the sum of infinity n equals 1, and I could give you like a fraction, right? Like 1 over n. Okay, and we know that as this goes to infinity and you keep adding them, this will go eventually to 0 because you're dividing by a very big number and you're adding, divide by a big number and add. And so actually this is not necessarily the right example because this doesn't necessarily go to 0, but I hope you guys understand the point is that even if I give you like a fraction, like I give you, well, actually here in this example, what they used is 1. And so if I take this and I divide it by 2, right? So I get 1 over 2. And I take between this and I divide it again. That would be 1 over 4. And I divide it again, 1 over 16. Or well, it would be 1 over 8, then 1 over 16. And you see, when I keep adding these, the sum of this will eventually go to 1. All right. If you don't understand this, don't worry. We're going to get more into mathematical examples if you understand that better. But the sum doesn't necessarily always go to infinity. See, in this case, it does. But in this case, it doesn't. It goes to 1. As you add all this up, as infinitely small fractions, and you add them all up, it goes to 1. Or technically, it would go to like 0.999999, and it just keeps going. And so, given a series this, let S is your series, okay? And don't remember, there's a difference between sequence and series. And there's different ways to do math around them. They're not the same. And we're going to go more over that. And so what this basically says is that if you take the limit of your series and it exists as at a real number, then the series is convergent. And here it says the number S called the sum of the series. Otherwise, the series is called divergent. So if you sum them up and you get a number, convergent. You don't get a number, divergent. And that's basically the same thing we did earlier. All right. But there's a couple different rules when it comes to series. An important example is the geometric series. All right. And this is what we're going to be tested on. There's a couple questions around this. And what this says is A cannot equal 0. If A equals 0, and we're going to go over that rule actually in a bit, so I'll skip that for now. The geometric series, all you need to know, you don't need to really remember this part. This is the most important part that you need to remember, and it's given actually. Okay? And so what this says, also you want to remember these two terms. This is not given, but yeah, you do need to remember these two terms. Let me see if it's given anywhere else. Yeah, it's not. Do remember these two terms where we are going to be using them. What this says is just your value R. If it's less than 1, then it's divergent. sorry, convergent. If it's more than 1, it's divergent. I messed up my wording there. You see, if R is bigger or equal to 1, the series is divergent. Okay, and so if R is between, if it's less than 1, then it would be convergent. Okay, and so we're gonna go over some examples here. Do the following series converge or diverge? If they converge, what is their sum? Okay, and so first we have to check if they converge or diverge. And from what we know in our formula, this is our formula, right? A, and our R is n minus 1. We know our R is n minus 1. Pay attention to this. Your R is n minus 1. So what is your R here? This is your R, right? Because it's to the n minus 1. And we know if R is less than 1, convergent, so we can get the sum. If R is more than or equal to 1, is divergent, and we don't get the sum because it diverges. And so how do we check? We just do, well, this is our R. R equals negative a over 3. And we know our formula is that the absolute of R has to be more than or equal to 1 for it to diverge. Here, remember the absolute. So the absolute of 8 over 3 is a number more than 1. So R is actually more than 1. So this diverges. Right? And so here we have 1 over n. The whole point of this is you just want to manipulate the question so that you get your n minus 1. Now, how can I get my n minus 1 here? If you look at this, and if, like, for example, if I have an x to the 2, and I take an x out, this will become, let's say, x to the n. And I take an x out, right? This will become x times x to the n minus 1, right? Because if I did x to the 2 and I took an x out, this becomes x2 minus 1, right? Or what it will actually look like, x times x, right? And so it's the same thing here. If I take this and I take a half out, right? So I could take a half out here. And so if I do 1/2, right, this is to the n. Remember, if you have 1 at the top and I raise this whole thing to the n, it's the same thing as if I did this. These are both the same. The only difference, the only way you can't use it is if you have a number at the top. The reason we can use it like this is because 1 to the n is just 1. So this goes away. But if our top was a 3, like this, we can't rewrite this as, because this means 2 different things. But if it was 1 over 2, and we raise it to the n, and we do 1 over 2, and we raise this to the n, this is the same thing. Because n to the 1 is just 1, n to the 2 is just 2 to the n, right? And so we can actually do this. So we can write it as this. We raised it. Now, if I take 1 over 2 out, I took 1 over 2 out, but then we get n minus 1. The same thing we did here. Okay? And so now this is your R. And your R is 1 over 2, which is half. Half is less than 1. And you see, if R is less than 1, it's convergent. It is convergent if R less than 1. So our R is less than 1. So now we can get our sum. You plug in your 1, and our 1 here is actually this. Right? Because this is your R. And you see A times R minus 1. So this whole thing is your Rn minus 1. And so this is your 1. And so it becomes 1 over 2 divided by 1 minus R. And our R is 1 over 2. And you just do the math here and get your answer. All right. For this one, so see, some examples like these are a little bit more complicated. If you are very good with manipulating the question and getting your n minus 1, you can. But in this case, it's not as easy, right? And so, I mean, one way you could do it, if, let's say, if you did see it, I'm trying to remember one way you could manipulate this. To be honest, I don't even see it. Like, I don't know. I wouldn't know how to manipulate this. So what is another way I could get my R? Now, we know from up here, remember how I said remember this part? We know our sum is equal to A plus A times R plus A times R squared and so on. And so, since we know this is a geometric series, well, we can say this is equal to A plus AR. All right? This is your n, your first term, n equal 1. This is your second term. Okay? Right? So first term, second term. And you're going to be thinking, oh, wait, why don't we start from 0? Because here n starts at 1. And so your first term is 1. Second term is 2. Third term is 3, and so on. Okay? And so how can we get it? Since we know this, then can I get my A? Let's get our A. I know my A is at n equal 1, so I can plug my 1 in here. So this will actually become, this will actually become, for my A value is 1 over 9 times, right, my over 9 stays the same, 6 to the n plus 1. My n is 1, so this becomes 6 to the 2, all over. 5 to the 1 minus 1 is 0, so this is over 1. Okay, so that's my A. I know my A, that's my first term, and it's at n equals 1. So that's my A, right? And so if I simplify this, 6 squared is 36. And so what this actually will become is 36 over 9. You can probably simplify this more, right? Now plus, I know my second term is AR is at n equals 2, right? That's my second term. And so can I get my second term? Okay, so let's get our second term. And so let's plug it in, which is n equals 2. And what I'll get is, trying to simplify this, so I get 6. 2 plus 1 is 3 to the power of 3, all over. We have 9 times 5 to the 1, so it's just 5. Okay, and that's my AR. Now, if I have an A, which is, 36 over 9, and I have an AR, which is 6 cubed over 9 times 5. Do you know? My brain is actually rusty. 45. There you go. Okay, now can't I just plug in my A in here and solve for R? And the answer is yes, you can. And so, what I get is 36 over 9. R equals 6 cubed, and 6 cubed is 36 times 6, which is 212, 216 over 9, right? This is what I have. Now I can take this to the other side, so I'll flip it and multiply, and what I'll get is actually I'll do it here. R equals 9 times 216 all over 36 times 9. And so obviously these two would cancel out, and this will equal to 216 divided by 36. And what I get is 6. And that's my R. And so now that I got my R, I know my R is more than 1, so this diverges. Okay? And so that's the other way you could do it. Actually, I made a mistake. I just noticed it. I made a mistake here. This is supposed to be times 5, right? Because this equals 64 over 45. 216 over 45. So, oops. I went a little too fast here. So this will actually be, this will stay 9 times this, and this, the bottom, will be 36 times 45. And this will equal 6 over 5. Alright? Which is still divergent. Alright? And so that is your other way you can get your R. Is that you can get your A by subbing in N1. You can get your R by subbing in N2. Sub in your A as well. Solve for R. Okay? And then, so here we have a dosage of a drug is taken each day. The drug decays exponentially with the rate R. So this is the drug decays is the decay rate, your R, in the bloodstream, so that the amount in the bloodstream after n days, n is in days, so, and rate R is the drug decay rate. And so we have this sum, and we know R is equals to 0.1. What dosage of the drug should be given to attain a long-term level after an infinite number of dosages? So we know we were taking the limit as n goes, and so this is n is the days, but we're looking at an infinite number of doses. And so this we're actually not taking n, we're taking d to infinity, I believe. But I mean, let me see, does this give you an equation? Oh, actually it does give you an equation, so it would be of n. Oops. So you see here, they give you this equation, right? And so this is the limit we're taking here as n goes to infinity of our function, which is d e to negative n minus 1 r, right? And so if we want to see if this goes to anything, and then here it says in the bloodstream of 2 milligrams. All right, so we're gonna leave these 2 milligrams aside for now, and what we want to see is first, does this diverge or converge? Like, is this function even viable? And so first we got to get our r, right, and see what it equals. Now there's two ways. There's two ways to get it. If you get e to the negative n, or I could do negative r times n minus 1, right? I'm just rewriting this part. Okay, what I can do is take this outside, so this will become e to the negative r n minus 1, and that's your r, right? The second way, which is the easiest way you could do it, is this is your a, right, plus this is your ar. And so if a is d, then this must be my r, right? And so my r, not this r, actually the lowercase r, and so my r equals e to the negative, well, we already have our big R, which is 0.1. Okay, and e to the negative 0.1 is 0.9, 0.9, which is less than 1. And so this converges. And so that's our first check. Our first check is we know that this is right. Now we gotta get our sum. And so the sum equals, we have our function, which is, a over 1 minus r, right? And obviously here it says what doses of the drug should be given to attain a long-term level in the bloodstream of 2. So we want the sum of the bloodstream. So here it says, so we know decay, so that the amount blood in the bloodstream. So you see the amount of the amount in the bloodstream. So this kind of gives it away that this equation gives you the amount of drugs in the bloodstream. And so if I am taking the sum of this in the bloodstream, then my sum, I want it to be 2 milligrams, because that's what it's telling me here. And so this will equal my a over 1 minus r. And so my a is d, right? And then my 1 minus, what's my r, is e to the negative 0.1. Okay? And now you could take this and solve for your d, because what you're looking for is what dosage of the drug. And this is, d is your dosage of the drug. Take this to the other side, you'll get 2 times 1 minus e to the negative 0.1 equals d. And that's your answer. Which of the following geometric series converges? And as we know, is that your r has to be less than 1 to converge. This r less than 1 converges. Okay? Here, what's my r? How can I solve for it? Can you manipulate this to get your answer? Yes. But what if you couldn't? Because this is n plus 1. Let's do our formula that we did. So n at 1 will become, my a is at n1, which will be 10 over 3 times 1 over 5 squared. That's my a, right? And then my r, my ar is at 2. So this would be 3, same thing. 10 over 3 times 1 over 5, except this is to the power 3. And now what you want to do is take this divided by this. So let's see what I'll get. 10 over 3. 10 over 3 times 1 over 5 to the power 2, all divided by the same thing, 10 over 3 times 1 over 5, all to the power 3 this time. And what I got is actually 5. And so this is actually supposed to diverge unless I did something wrong. So it's this. Oh, I switched mine. I did this squared divided by. Dang, this is why calculator stuff. Like, why can't I just take a picture of this and do the math? Anyways. Yeah, I got 1/5. Oops. 1/5. And so this actually does converge because it's less than 1. Okay. The other way you could do this is if you want to manipulate it, which is the faster way. Oops, my alarm went off. The faster way is what we can do is take 105 out. So this will be 10/3, and I'm going to take 1/5 out. And so all I'll get is 1/5 n plus 1 minus 1, right? And so this will become just n. And if I take another 1/5 out, what I'll get is 10/3 times 1/5 times 1/5, 1/5, and minus 1. And that's my r, right? And so that's the second way you could do it. And you see, when I put in my calculator, I knew that it doesn't diverge because I knew the simplification for it. And if you know that, it does come in handy, just in case you confirm your answer. Now here, same thing. I can take a -7/4 out. It becomes a -1. This is more than 1. It diverges. Okay, so I hope that makes sense. What I did, 1/6, I took a -7/4 out. So then this -7/4 became n minus 1. I explained that earlier at the top. Now here, how can you solve this and find your r? We have 0.3 to the n. Same thing. Take 0.3 out. You'll get 0.3 to the n minus 1. And so this converges because 0.3 is less than 1. Okay, we have one more page left. I'm not going to go over this theorem because we're going to cover it right here. All right. So for divergence, this is specific to series. Okay, please do not use this on sequences. You cannot use this divergence test on a sequence. You can only use this on a series. Okay, so what this says is if you take the limit of n, if you take the limit of n equals to infinity of your a of n, and it does not exist, or if it does not equal 1, right? It does not equal 0. So this says is if you get infinity, or if you get negative infinity, which does not exist, or if you get dne, or a does not equal 1, does not equal 0, then the series is divergent. This does not confirm convergence. So if your a does indeed equal 0, it does not mean it converges. It just means it doesn't diverge, but it doesn't mean it's convergent, right? So if your a does not equal 0, divergent. If a does not equal 0, diverge. But if a equals 0, inconclusive. I'm pretty sure I spelled that horribly wrong, but get the point. All right, it's not convergent, it's inconclusive. Okay, and so what does the divergence test tells you about the following series? You want to take this. This is your a of n, right? And so what you want to do is take it to infinity. As n goes to infinity, what happens? This goes to 0, right? And so when I take the limit as n goes to infinity of 1/n, then this goes to 0. And so this is inconclusive. Conclusive. Okay? And now doing this one. Same thing with limits. The only difference is it means differently if you don't get a number, right? Because you're doing series. And so how do you take the limit of this? What you want to do is, like we said earlier, is divide by the highest power of the denominator. So divide by n to the 5, divide by n to the 5, divide by n to the 5. Same thing, n to the 5, n to the 5, n to the 5. And what you'll get is 7/3. So actually I'll do the top minus 3/n to the 3 plus 1/n to the 5 all over. Okay, I don't know why that line didn't straighten out. 3 plus 4n to the 4 all over, well, it wouldn't be n to the 4, it would be n. Actually, sorry, it would be n here. Plus n to the 3 will just be 1 over n to the 2. Okay, so now what happens here is when you take the limit, when I take the limit of n to infinity, this goes to 0 because I'm dividing by a big number. This goes to 0, this goes to 0, this goes to 0. And what I'll be left with is 7 over 3. And 7 over 3 is not 0. So this is divergent. Okay? Here I'll write it. This does not equal 0, so it diverges. Okay? And you see here it went to 0, it became inconclusive, but here it is not 0, so it's divergent. Alright, and so which of the following series of the divergence is inconclusive? So we're looking for something that equals 0. Inconclusive means it equals 0. So when I take the limit of this, does this go to 0? Well, I know when I take the limit, this will go to 0. So actually, I'll use a brighter color. This will go to 0. Sine of 0 is 0. 7 times 0 is 0. So this actually goes to 0. So it's inconclusive. All right? Take the limit of this. Goes to 0. Inconclusive. Okay? Because 1 divided by a big number is 0. Here. Take your exponent to infinity. Okay? And when you take the exponent to infinity, what you'll get here is, so if we go on my calculator, this is how I always like to confirm it. If you go on your calculator and I put exponent to the very big number. Okay? So if I do 0.3 and then I put big number, what you'll see in your calculator, this will actually equal 0. Okay? And so this whole thing goes to 0. Pi times 0 is 0. So this goes inconclusive, right? Here, same thing, you want to divide by the highest power, which is 3. Right? Okay? And so when you do it by 3, what you'll get here is this will cancel out, you'll get 7. This top one will go away, and you'll get 1. This one will stay the same. This one will stay the same. This one, the bottom will go away, and this will become a 2. And so when I'm doing it this way, and then I take the limit, this one is 5 over n, it goes to 0. Right? This one's 2 over n, this goes to 0. I still have a 7 in the denominator. This one, 1 over, this goes to 0. What I'll be left with is an squared all over 7. When I take the limit of this, this will go to infinity. And since it's infinity, it is not inconclusive, because remember, inconclusive means this has to go to 0, but this does not equal 0. And so it is not inconclusive, it's actually divergent. So it diverges. Okay? And consider this, does the sequence converge? You see, yeah, so remember, this is what I just made a big deal about earlier, is that this only works with series. Okay? And so this is saying, does the sequence converge? How do you check if the sequence converge? You take the limit as n goes to infinity of 6, 1 over n. Okay? Which is the same thing you would do with the series. It's just what the result is means different things. And so since this is a sequence and we take the limit of it, 1 over n goes to 0. 0 of 6 is just 1. Right? This just equals 1. Now, if we were doing a series, then what does this mean? This does not equal 0. That means it diverges. But since this is a sequence we're dealing with, if it's a 1, it's actually convergent. Okay? It converges. Okay? Now, does this converge? This is now a series we're working with. And so, does this converge? No. It diverges because so it diverges because 1 does not equal 0. And if it does not equal 0 for a series, it's divergent. So A, it's convergent. B, it diverges. Okay? So I hope that helps. Yeah, when you're taking for a series, when you're taking the sum, it's the same thing you would do with like the integrals. If you have a constant, you can take the constant out. If you have adding, you can just take the sum of this plus the sum of this, or minus, vice versa. So nothing too much here. So here we'll do this actually right now since they didn't do it in the lecture, and I haven't done either. So what we're doing here, we're taking the sum of this, and so if we're trying to take the sum of this is a series. We're gonna take the R. So first we gotta check. Okay, I'm talking too much here, so let me calm down for a bit and start over. This is adding. Since I want to get the sum, I can split it into this. Okay, so what I can do is the sum as n equals 1 of 3 to the 1 over 4 n minus 1 plus the sum. See, now I'm splitting it into two parts. N equals 1, and then I have 5, 1 over 2, n minus 1. Okay, so before I get the sum, if we go up, where is it? This is it. Before we get the sum, first we got to check our r. R has to be less than 1 for both of them. Or else, you see, if r was more, one of them will diverge. And so, let's get our r. Our r here, 1 over 4, is less than 1. R equals 1 over 4, which is less than 1, which equals convergent. Okay? Or, well, yeah, so it is convergent. You could say that. And then my r for the second one is 1 over 2, which is less than 1, which is also convergent. So now that I know, I could actually take the sum. And so to take the sum, I know my formula is a over 1 minus r, right? Plus a over 1 minus r. And so what you'll get is this is for this part, and this is for this part. And so what I can do here, this will equal my a, which is 3. This is your a. And my r. How do I know this is my a? I know it from up here. Your first, from here. Your first term is a, and your whatever is to the n minus 1 is your r. And so n minus 1, this is your r. And then whatever's outside is your a. Okay? And so 3 over 1 minus my r, which is 1 over 4, plus my here 5 over and 1 minus my r, which is 1 over 2. Now plugging this in the calculator, we should get 14. So 1 minus 1 over 4 is 3 over 4. So if we do 3 divided by 3 over 4, we get 4. Now we got to do the same thing for 5. 1 minus 1 over 2 is just 1 over 2. 5 divided by 1 over 2 is 10. Plus 10. And this equals 14, which is the answer we have. Okay? I hope this helped, guys. Good luck on your exam. And if you guys need any help, please write a comment down below for a question that you don't understand, and I'll make you a short video.